Inequalities with two or more steps. So we have properties of equality, and inequalities are similar to equations in solving. You can add, subtract, multiply, or divide any amount to either side as long as you do it to both sides of the equation or inequality. So for example, we have a problem like x minus 6 is less than 10, and we're asked to solve and graph the solution. We can undo what's being done to the variable x, so 6 is being subtracted from x, so the opposite would be to add 6. If I add 6 to one side of the inequality, I also want to add 6 to the other. On the left side, negative 6 plus positive 6 are inverses. They cancel out or zero out and leave x. And 10 plus 6 is 16, so my solution is x is less than 16. And to graph that on a number line, I have an open dot on 16, and then I want to shade this side with all the correct answers. Well, 6 is less than 16, 8 is less than 16, so I'm going to shade this side because all these answers work. And it's an open dot because I want to include everything up to 15.999999, which is less than 16. So I want to have an open dot here to show that I'm including everything up to 16, but not 16 itself. So when it comes to inequalities, we want to use an open dot for greater than or less than, and we want to use a closed point or a solid point if we have any part of an equal sign, like greater than or equal, less than or equal, to show that we're including that point on our solution set as part of the solution set. How would you write the statement, he exceeded the speed limit of 50 miles per hour using inequalities? Well, I'd pick a variable, any letter you like, and we have the number 50, and then we have to think about what symbol would go between the two. Are we talking about greater than, less than, greater than or equal, less than or equal? And for exceeded, we could use greater than, because we're not including 50, we're including everything greater than 50. All right, you guys try to solve and graph this inequality. Pause the video here, come back and see how you did. All right, welcome back. So what I would do first is to undo that plus 8 to the variable. I would subtract 8 from each side. Then we have y is greater than or equal to 7 on our number line. That would be a positive point on 7. And all these answers would work for y. 8 is greater than or equal to 7, 9 greater than or equal to 7. So I'm going to shade this direction with all the solutions that work. What if we're just given a graph and we're asked to write an inequality based on the graph given? Well, I have a solid point on 4, so we're including 4. And it looks like all the numbers greater than 4. So if I were to write that as an inequality, I would do y or x or whatever variable you pick or choose is greater than or equal to 4. Remember, greater than or equal include that point from the number line as part of the solution. All right, the most important thing you're going to want to write down, you're going to star by it, you're going to highlight this. When you're multiplying or dividing each side of an inequality by a negative integer, you must reverse the order symbol. Meaning if you have greater than, you need to make it less than, greater than or equal needs to switch to less than or equal. So if when we're in the process of solving our equation, we multiply or divide both sides by a negative number, we have to reverse the inequality symbol. Otherwise, we end up graphing answers that don't work in the original problem. So it has to be done. So for example, if I have negative 4x is greater than or equal to 12, I solve by dividing both sides by negative 4. Then negative 4 divided by negative 4 leaves 1x or x. On the right side, 12 divided by a negative 4, positive divided by negative is a negative. So I get negative 3. And I have to switch this greater than or equal to less than or equal because I divided both sides by negative 4 while solving. Then I could graph on a number line, solid point on negative 3, and shade to the left. Do you change the sign if you multiply or divide a positive number while solving? No, 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 no. You do not. So let's look at some problems and see would we switch the sign. So do you change the sign if you're solving negative 15 is less than or equal to 5a? Well, to solve that, I would divide both sides by positive 5, so I would not flip the sign. How about y over 4 is greater than negative 20? I would solve by multiplying both sides by positive 4, so I don't switch the sign. What about negative 3m is less than negative 33? I would divide both sides by negative 3 to solve, so I would have to flip the sign. I'd have to change that less than to greater than in my solution. So if you multiply or divide both sides by a negative number while solving, you have to switch the inequality sign, the direction. All right, so let's say I have 7x plus 29 is greater than 15. To solve, I would subtract 29 from each side. Get 7x is greater than negative 14. Divide both sides by 7. Since I'm dividing by a positive 7, I don't switch the sign. I end up with x is greater than negative 2. To graph, open point on negative 2 and shade to the right to include all the positive solutions that work for x. So if I put negative 3 in for x, negative 3 doesn't work. So notice how that's not in the shaded area. But anything I put over here, if I put 3 in, 3 is greater than negative 3. So all the points on this side work. So my shaded area is going to include all the correct solutions. Well, if you've done equations with variables on both sides, you can also apply these rules to inequalities with variables on both sides. So in this case, I have a b on one side, 3b on the other. So I don't have parentheses to worry about, distributive property or like terms, but I do want to get all my variables to one side. So I could start with subtract b from each side. That's going to leave me with negative 8 is greater than or equal to 2b minus 8. Add 8 to each side. 0 is greater than or equal to 2b. Divide both sides by 2. And I get 0 is greater than or equal to b. Dividing both sides by a positive 2, I do not have to worry about flipping the sign. Then I could graph that with a solid point because it's including an equal sign. Remember, equal, greater than or equal, less than or equal would be a solid point on the number line. All right, you guys try this one. You got a variable on both sides. Solve the inequality. Come back, check, see how you did. All right, so I have a negative 4w and a w. So to get my w's to one side, I either need to add 4w to each side or subtract w from each side. I chose to subtract w from each side. The work will be different, but your solution at the end will be the same. So w minus w zeroes out and leaves negative 21. Negative 4w minus w is going to be negative 5w. Then I could subtract 9 from each side and divide by negative 5. So w is greater than or equal to 6. And I hope that helps you guys with solving inequalities with 2 or more steps. Have a great day.